Hey everyone, we're going to take our third day of class notes on 12-2, where we're still dividing radicals, so we have to work on getting the root out of the bottom. In the bottom though, we're going to have a binomial, so we're going to have two terms. We're going to have something that either looks like this or like this. And to rationalize, to get that out of the bottom, we use what's called a conjugate. So if I see a problem that has a subtraction in the bottom, then I'm going to multiply both the top and bottom by its conjugate, which has a plus sign in the middle. If in the bottom I see something that has addition in between, I'm going to multiply top and bottom by its conjugate, and I'm going to make sure to use a minus when I'm multiplying. So if that's not clear, watch the examples and you should hopefully see what I mean by that. Our first example, I have 2 over the square root of 6 minus 4. So this is where I'm saying we have a binomial in the bottom, two terms in the bottom, and we can't have the root in the bottom. And so to get rid of that root in the bottom, you multiply the top and bottom by its conjugate. This one has a minus, so I'm going to do a plus. Conjugate's going to be opposite sign. The root 6 and the 4 stay. So root 6 plus 4 is the conjugate. Root 6 plus 4 is the conjugate. Then what we do what we did 2 days ago. We distribute and we multiply. And so 2 times root 6 is 2 root 6. And 2 times 4 is 8. In the bottom, I see, if you remember the sum and difference pattern, you can just, the pattern says you can square the first. It's the a squared minus b squared. I'm actually going to write that over here. This pattern comes from chapter 10, where if we have a problem that looks like this, we can use this pattern. So I'm actually going to use the pattern here. If you don't want to use the pattern, you can FOIL or distribute. Root 6 times root 6, root 6 times 4, negative 4 times root 6, and negative 4 times 4. If you decide distribute, your terms in the middle, 4 root 6 and negative 4 root 6, will cancel out anyways. And that's why we can use this pattern. So when I take the first and multiply, I get root 6 times root 6, which is root 36. Or again, if we square that, you know that the squared in that will go away, and that's going to become a 6. And then subtractions in the middle of the pattern, and then we just square this, or 4 times 4, negative 4 times 4 is a negative 16. And so the top's going to stay 2 root 6 plus 8 over, this comes out as 6 minus 16. So top stays 2 root 6 plus 8. Remember, I can't put these together because this doesn't have a root 6. And 6 minus 16 is a negative 10. Now, if all three of your numbers outside have something in common, you can reduce. So I'm going to reduce those all by 2. This becomes 1 root 6. Reducing this by 2, I get a 4. And reducing this by 2, I get a negative 5. Final answer for this one. Next, I have 3 plus root 2 in the bottom. So conjugate is going to be 3 minus root 2. In the top, we distribute the 1. We get 1 times 3, which is 3. And 1 times negative root 2, which is negative 1 root 2. In the bottom, we multiply our first. 3 times 3 is 9. We distribute and we get negative 3 root 2. We distribute, we get positive 3 root 2. Well, a negative 3 plus 3 is going to give us 0. So those will cancel out, and then I can just multiply these. And they're both under, so I could take the 2 times 2. I'm going to get a negative root 4. So I get 3 minus 1 root 2 over 9 minus, this is perfect, so it comes out as 2. That's our whole goal, is to have that be perfect. So that one was perfect, it came out. This one's perfect. We don't want a root in the bottom. It's okay to have a root in the top, just not in the bottom. So I get 3 minus 1 root 2, and 9 minus 2 is 7. Now my three numbers this time have nothing in common, so that is my final answer. Our third and final example. Here's the binomial. We want to figure out what is its conjugate. The 8 and the root 11 stay the same. If we see a minus here, we know that we're going to use a plus when we multiply. 8 plus root 11. Distribute. 5 times 8 is 40. 5 times root 11 is 5 root 11. Again, we can't put these together. Please don't say 45 root 11 because they're not like. This would need to have a root 11 in order to do that. In the bottom, when I distribute 8 times 8, 64. When I distribute 8 root 11, distribute negative 8 root 11. Those are going to cancel out. And then I'll have a negative root 121, which is perfect. Any root times itself is just the radicand, and maybe that's a pattern that you're picking up on as well. That if we have a root times itself, we're just going to get the 11, no root necessary. I'll show you. 121 is perfect, and it comes out as 11. So this will turn into 11. I get 40 plus 5 root 11 over 64 minus 11. So I just subtract these because they're both outside and they're like. Can't add here because they're not like. And I'm going to get 53. 4 minus 1, 3. 6 minus 1, 5. 45 and 53, the three numbers outside, they don't have anything in common. I am finished with that problem. Let me know if you need some help. Have a great day, everybody.